After this long journey, now we have come to modern climate change, which is mostly since the Industrial Revolution, which has been reported in the media now for a while, and now pretty much every day in every language, anywhere in the world, there are climate stories being reported on the impact on floods, droughts, forest fires, health, anything and everything, right? So why is the climate change as we see it so controversial? So this is one a good example of why, how this can be used. So CO2 concentrations have been measured since the 1950s, started by Charles David Keeling at Mauna Loa, and now reconstructions have been done going beyond that. And we know that this is increasing. In fact, now we are already over 415 or so. And the temperature deviations from the long-term mean, or the base period, sorry, is that the temperatures were below the base period of 1960 to 1990 when we started the Industrial Revolution, flipped to positive and then oscillated around it during the Second World War and a few couple of decades after that. And since the mid 1970s, especially from the beginning of 1980s, it seems to have taken off. These red bars here show the increase in warming. When we talked about the global warming pause, we talked a little bit about slowing down of the warming rates and so on, but the energy companies and other corporations that had vested interest in arguing that humans are not causing climate change used these to show that the CO2 increases monotonically, whereas temperatures always go up and down, and the climate change we have seen so far to say that climate always changes. There is no evidence for human influence, human interference in climate variability and change. Okay, but of course we know already from this paleoclimate things you learned, paleoclimatic climate variability we saw. Little change in sun's energy input, for example, can trip off internal feedbacks and amplify the climate signal and produce huge ice ages or deglaciations and so on, right? And CO2 has varied a lot in the past. During the time of the dinosaurs, we said temperatures were much warmer. CO2 was much higher as well. It was more than 1,000 ppm, whereas now we are at 415 ppm. Plus, these ups and downs in temperature anomalies are because the ocean can hide the energy, as we saw with the global warming pause, and it can go into glacier melting. So glaciers are obviously melting already on Greenland and parts of Antarctica. And that is called natural variability. As we said, El Nino releases the heat from the ocean that had been stored from the previous El Nino and creates a mini global warming. And there are other processes like the Atlantic meridional overturning, which happen Atlantic multi-decadal oscillation AMO, which happens on 60 to 80 year time scales, also can contribute to these kind of warming and cooling. So considering the humongous heat capacity of the ocean, we have to look at the patterns and try to see if in fact we are warming the planet, or is it just a claim. So this shows temperature mean anomalies every 5 years starting in the 1800s, and you can see I will run it a couple of times, and you can see that it starts with negative numbers in most places, as we saw in the average signal, and slowly it begins to become red over most regions, and by the time you end, you can see that it's red everywhere except for a couple of spots, which we will see again. Okay, so the spot here remains negative, for example, at the end of the time period in 2017. Obviously, anytime you see a temperature signal here, what comes to mind? Deep water formation. right? So Atlantic meridional overturning circulation would have to have something to do with that, with contributions from other processes as well. So you can see that the temperature anomalies have become warm everywhere, and because of the dynamics and the feedbacks between the vegetation and the atmosphere, soil moisture in the atmosphere, ocean redistribution, and so on, it will not be uniform warming, which is what we had mentioned when we talked about feedbacks in the Earth system. There is also more warming near higher latitudes than in the tropics. You can see much more red at the end in high latitudes because of this something called polar amplification, which again is related to ice albedo feedback. So you have lots of snow and ice here at high latitudes and the glaciers here over Antarctica. And if you begin to melt, we saw that there is the albedo change, increased energy absorption, more warming, and so on. So obviously the warming is much higher in magnitude at high latitudes. That is called polar amplification. Okay, how do we know this is actually caused by human action? There are simple things. You can look at the CO2 in the atmosphere, look at the isotopic composition, and know that the increasing CO2 has a signature of fossil fuel burning. For example, I talked about C14, but during photosynthesis, more of C12 is taken up than C13 because it's energetically efficient to take up more C12. So the fossil fuels, which are biological material from the past, have more C12 than C13. So when you burn them and release more CO2 and CO2 increases, you can actually measure isotopic composition to say that actually came from burning fossil fuels and old hydrocarbons. You can also measure the drop in oxygen associated with so much fossil fuel burning. So that's also measured, surprisingly, or maybe fortuitously, by Keeling's son, Ralph Keeling. So Charles Keeling started measuring CO2. Ralph Keeling at the Scripps Institute of Oceanography measures oxygen. There is plenty of oxygen, nothing to worry about, but still all the fossil fuel burning shows a clear signature of drop in oxygen. The concept of detection and attribution basically is that we can detect a change. Temperatures have warmed over this long period, and we can use various methods to ensure that this signal is real. So that is detection. And attribution means we have to show what caused this change. Is it natural climate change or is it human activities? That can be done often using models, where in the model you increase the carbon dioxide and show that the model captures the observed warming realistically, so you know that the model is working. In the model, you can also take out the carbon dioxide and not let it increase over the integration. So you can see that multiple models have been run. This shows the multiple models are producing the observed warming. The dark black line is the observed from data, and the red line here is the model simulation, the average of all the models. Okay, and here the observed, I hope the observed is black. Either way, if you take out the anthropogenic carbon dioxide in the simulation, then you don't get any warming in the 20th century, especially at the end of the 20th century. This tells you that you can confidently attribute the warming to human activities and human emissions of carbon dioxide. So we can measure carbon dioxide accurately and precisely, and it lasts a long time in the atmosphere, and we know isotopic composition, so we know that. And then using these attribution exercise, we can confidently say the warming is related to, is caused by CO2 and other greenhouse gas emissions by human beings. Okay, this is to reaffirm our ocean concepts. This is the increase in ocean heat this is the Earth's average temperature here, and this is the invasion of that heat into the ocean in the top 700 meters. and you can see again the evidence of polar amplification here, and the AMOC and the lack of warming here, and so on. So the dynamics of the ocean redistributes the heat, obviously, as we talked about, whether the East Pacific has warmed more or less than the West Pacific, but this is the heat content averaged over 700 meters. The other thing that assures us that the heat is invading the ocean is that when you look at the deep water formation sites, the surface warming has penetrated much deeper. Similarly, in the subtropical gyre, where the surface waters converge and are pushed down deeper, and the upwelling regions, the stratification and upwelling of colder waters doesn't allow the warming to penetrate as deep. The Southern Ocean warms and the heating penetrates deeper here as well. Okay, US and Europe and the polar amplification in the north, that is much more obvious than the Southern Hemisphere because of the Southern Ocean modulating the warming. The penetration of heat in the northern hemisphere is much more. There are other evidences like decrease in the Arctic ice cover. Arctic ice, especially measured at the end of summer, has been shrinking actually every month since the 1980s. Some people would argue that this is not long enough to say this is actually human-caused change. But when you look at the consistency between the temperature increase, humidity increase, sea level rise, glacier melt, ocean warming, and so on, you can conclude that in fact this is related to the polar amplification and the warming, and this is part of the polar amplification, because as the ice extent decreases, albedo increases, ocean absorbs more heat. Okay, so all these evidences are there. I will come back to the further details. This is already 12 minutes long, so I will continue this thought a little bit more in the next podcast. Okay, so I hope it's clear. Detection of the warming is easily made now. Attribution is made using models to show that the increased CO2 by human activities is necessary to explain the warming that's been observed since the Industrial Revolution. Okay.